ngasi topic sidi Gauss law gi ani suba application ni field due to a uniformly charged infinite plane sheet se sida sida diagram ye isini sida ye isi kitang yengba nungaite ana karlay mongam ye abani sida lazy this is an infinite plane sheet of charge ni charge ko na positive na to ina law re positive law re adagi di magi surface charge density je sigi sigma sinen law re sigma equal to if sigi area je a charge by area oi bani let a sigma be uniform surface charge density of an infinite plane sheet. We take the x-axis normal to given plane. X-axis is plane is normally low rehab ni som nakan jida mawandagi kaptor ko matamda plane is yang matamda 90 degree hele. By symmetry, the electric field will not depend on y or z coordinates and its direction. At every point, and its direction at every point must be parallel to the z direction. Electric field में आंदे स्माइना लाइव निकंग दे स्माइल लाइव निकंग दे लोई ले दबने. We can take the Gaussian surface to be a rectangular parallel pipe of cross-sectional area A. So इसी तरह लो इसे parallel pipe सिगी सिनी को इसे इसी तरह लो इसे मधुकर सिगी area से ना कमाई तो क्या मतलब cross-sectional area से ना A or lab sigi area से कोई A or lab अदुने हाई से sigi से सीधे जो पल्ले a cylindrical surface will also do cylinder law so क्या हम कायदे कोई मांग लो लोगे तो minus cylindrical law जो यार मुझे symmetry ना है बने ना मैं यार देखो खन मतलब दा मानवा अनी फंगदो इनी ना याद यार बा Gauss law पान बता दी सिंग मुझे क्या हम दा कायदे. As seen from the figure, only two faces 1 and 2 will contribute to the flux. Electric field lines are parallel to the other faces and they therefore do not contribute to the total flux. So this is the surface contribute to the issue. This is the man of 1 and 1 is 2 aduga remaining is 3 boy 4 boy अतई सरफेस ने दी कमाई तौने मतमदा इलेक्ट्रिक फील्ड गा येंगा मतम जिदा मोइसे केमत फंगारोय आइदी फंगतु इसे मो इलेक्ट्रिक फील्ड से सोम नाकन चले एरिया से सोम नाकन चले अदुई तारी मोइनी मार्क लेबे एंगल से थीटा सिना 0 कान कोसिना 0 कान कोइ एनो होलिदन अमा सोम नाकन गी मथकी कैका येंगा पददी 90 डिग्री लेनी area sigi surface ki lay matam da si mathak ta kara ani adu electric field ga di 90 lakani dana aduna atai surface na di contribute to roy flux siga aduni hai je songi 1 ziga and 2 ziga contribute to ni 1 and 2 ziga moi jing jina parallel oina lay na electric field as well as area vector ziga. The unit vector normal to surface 1 is in minus x direction while the unit vector normal to surface 2 is in positive x direction. Unit vector surface ki unit vector hai ro amana som na consider laire amasina nakanda minus som the opposite te laire. Therefore the flux through both surface are equal and add up. Therefore the net flux through the Gaussian surface is 2EA. That now na summary. Sigi mamang da hot kibda su kamain tau gaya matam da si cylinder gi oiraga akoy na hot kibda su kamain tau we ani je plus tor khidana sigi na left side ki amana right side ki hot matam da samana na taraga plus tau bidana adugi idea aduni se sida um por to ise ibadi adum iramagi yangu aham bagi de yangsi flux 1 gaya one side ki E dot A hairani E magi di kamain tawre minus ni kino tholak tu isi E A cos theta sumai lak tu ne si lak tingai da pura thukal asi E dot n cap ki mahutta minus n cap lak tu ni magi direction je ngo aduna sida minus irage E dot n cap then area sumai lakani minus laser sanu E A cos theta degree mutta 180 degree irage this is minus 1 ni and therefore man tar to ise E A tar ani som area som giti E on the 2 gida di phi 2 da di kamain tawre magi dane hel lare E dot A laser E A cos 0 degree la ani magi dana aduga kamain tawwa E A kakla ani because cos 0 is 1 ina adu maina ani ji tin janna tar gadi kai tare total flux hai phi 1 plus phi 2 ni ani ji zamana twice E A tare adu ni ji da is the net flux total flux through the Gaussian surface is 2 E A and high se then say ji da masu ire kharam maru oiba the charge enclosed by the surface is sigma A sina kamain lakpa now sigma equal to charge by area ni and therefore charge ai targati the multiplication between the product of sigma and A charge si object hai give do sigma A ni aduna kamain tawre object flux isu twice E A na fangre Gauss law panam tamnadi phi equal to q by epsilon naught ni q se kai enu jikta hai gre sigma A ne na adoi targati ani se equate to ya ni equate tor ko matam de mo is the layer 2 E A se kai tare sigma A by epsilon naught ega thana gre aduna ne koina object area lo bada cylindrical gi lower su ya ai do dum lon ka thana gre dabni aduna E is kai tare sigma by twice epsilon naught sina magnitude vector form the d n cap yore n cap sina hai kai no is a unit vector normal to the plane and going away from it positive with the away from it negative or na towards the obviously sheet or plate se oi doi ne ba the minor vector or gana n cap happy raga loy sigi n cap sina unit vector going away positive kina then towards negative kina oi gani the minor sigi sida noi na su yeng jan ba yai positively charged infinite sheet ani gi marakta di electric field se kamain tarongani kya oi ge ga naga adu masu yeng jalu isu maru oi bani sina ohum suba application ni fill due to uniformly charged thin spherical shell let sigma be the uniform surface charge density of a thin spherical shell of radius r the situation is obvious spherical symmetry sphere the mai ai the khaidat pan matam da nakan ani di sung so isoi na dum loi manaradam ne anywhere mai ai the khaidat matam da the fill at any point outside or inside can depend only on r the radial distance from the center of the cell to the point and must be radial that is along the radius vector I remember kari no loina ma yengaksi electric field due to spherical shells in a sigi blue is the lazy later aduga mapanda electric field kamain tawgani manung dana kamain tawgani and surface dana kamain tawgani habdo makan je ko yeng toini amde yeng siango consider outside ki da yeng dore consider a point P outside the shell with radius vector r vector to calculate E vector at P we take the Gaussian surface to be a sphere of radius r with center O passing through P. Sida khanare han pyramid se radius r leiba shell ama leizare adai da akoina point P akoin puthokningi se point P se ne electric field se electric field intensity sigi sida magi center dagi sibuk lap radius oina lawraga akoina pei oina ye is the sphere am ye sin Gaussian surface sphere oina ye. All points on this sphere are equivalent relative to given charge configuration anywhere so I mata electric field me amje loinma mana doini then point me am la pakotpa loinma mana ni sphere am. That is what we mean by spherical symmetry. The electric field at each point of the Gaussian surface therefore has the same magnitude to and is along the radius vector at each point. Thus, anywhere see points radially or doing see points radially or doing minor loy hibernate. The electric field vector and the surface element vector at every point are parallel and the flux through its element is E del S. Sigi sidagi bulawreng khalo si electric field su radially outward wairani surface su chap manana mazu kaino wairani radially outward wairani sigi su mapa chap manana sidagi dum thola ani moeni se parallel waire theta is 0 wairani aduna kamain tawre at every point through this surface magi electric field intensity flux magi flux loi manarni E del S loi wairani was ke kamayam de muwan cha khadamni na was 0 di aduna kamain tawre sina macha point angkhatang macha angkhakini summing over all del S the flux through the Gaussian surface is magi si surface area of a sphere si del S hai be mohta pulap ki yeng taragadi sina achang khakini yeng ji point P khakini yeng ji pulap ki yeng taragadi phi hai taragadi E S lakuni S is the surface of that sphere aduna E 4 pi r square r is the radius si asang the radius of the sphere se oidoina silani. The charge enclosed is charge na kamain tawre manung dele am there charge na object hai gi surface the charge density the q by area oidoini area the 4 pi r square sidana r chobu area se kai gino hai matam da charge na leidoi je charge na leidoi je sigi blue gi sidane sigi sidani charge leidoi je aduna ni kumagi radius oina lawri ise aduna q have the kai tare charge is this times 4 pi r square ne aduni se jide is adu tare ga dore akoi Gauss law pan be yarni Gauss law na kai hai that phi is equal to q by epsilon naught so q is the 4 pi r square sigma layer divided by epsilon naught sida value am bhange so value am bhange ani se equate to birani koina equate to rani ani se equate to matung na kai dore rearrange kitang tok thoko matam da phangi se mu smaina phange or sigi sigma se in terms of q don dor ku matam da mu smaina phange that E equal to 1 by 4 pi epsilon naught q by r square. Sige q sini is the total charge on a spherical shell and I say vectorically r cap am ape r cap sina tak to ise kaino ma se radially outward oidoini positive varigana radially inward oidoini kusigi charge negative point aragadi adu minor ma legere then fill inside the shell the mind of game se sini inside the shell oidoi se see inside the shell oi matam sida kamai to game tam da when a flux hotmatamda charge by epsilon naught hai sigi charge ki matang yeng doi ne ko na at point mana say the p and lore manung jida dagi Gaussian surface di manung da piktak na leire aduga charge di mapan doi na leithokre Gaussian surface na does not enclose any charge mana enclose amta tawdre charge aduna sigi charge is 0 lani and therefore flux will be 0 aduna say tharam doi si the point P is inside the shell. The Gaussian surface is again a sphere through P at center O. The flux through the Gaussian surface calculated as before is however, in this case, the Gaussian surface encloses no charge. Charge enclosed on the E 4 pi r square. E dot s I 0 by epsilon naught commander any meaning 0 commander any and therefore electric field is 0. Electric field is 0 if r masasina so budagi pick targadi r masasina pick targadi manung lay targadi hain then manaram targadi kamain torani manaram targadi sigisida yengo r achobasiga r machasiga manaram bahibani ado itaragadi e c sigma by epsilon naught simply sida loi bi are sigisine ta doisi sida loire akoi gi chapter su sigi mathang da angka khara utke holaga exercise tagi ngatlaga amani